Hey, how's it going? So in this tutorial, we are going to be making the game of Snake using Pygame. And Pygame is kind of a basic video game engine used in Python in order to make graphics in your simple video games. Um, Modern game engines are certainly far more complicated, but this allows us to do at least some simple graphical stuff. So when you start your game, it's going to look something like this. And we're going to discuss what each one of these things do in just a moment. But first I want to show you what it is that we're going to be making so we can understand why we're making the different design choices that we are. So this is going to be the game that we are making. Just simple squares, and that blue represents our snake. You can see after I ate one of the red things, it grew a little bit longer, and just keeps on going around until we run into a wall or we run into ourselves. And then it stops, restarts, and we play again. So really, really simple. The entire code's only about 100 lines. So pretty short. What I want you to notice is that everything was kind of pixely. So we weren't actually doing everything by a pixel, but we made everything kind of blocky and pixely. And we're going to be using that as kind of an idea of a grid. So we're going to split up the entire screen into a grid of blocks, and every snake segment, as well as the fruit that the snake eats, is going to occupy one little block. And that is going to be how we kind of think about creating this thing. So, start off with, let's look at the code that we start off with and see what it actually does. So we see that we're importing some stuff up here. We're importing Pygame because we're using Pygame. Sys is actually only being used right here. It's the only place it's ever going to be used in this program. And that just stops the program. So nothing really interesting about that. And then it also starts off with this, importing from Pygame locals, this quit. This is not a method or a function. This is actually just a static variable. And it's being used right here. So we start off, we initialize Pygame. This kind of sets up all the Pygame stuff and gets it started. We then create the game window. That's what this line is doing. So Pygame displays set mode, creates the game window, and it takes a tuple or a list as a argument, and this is going to be the size of the window that we are creating. So right now it is making a game window that is 400 pixels wide and 300 pixels tall. So it's pretty small. This then sets what is shown up at the top, and then we get into the main loop. So we could actually hit run right now, and we'll see some of the stuff that's going on. So right here we see hello world. That's being done by this. We don't want it to be hello world. This is a game of Snake, so that's called Snake. And now we'll change what this says up here. Here we can see how long our window is. This is 400 pixels. It looks a lot on my screen, but that's because I'm just zoomed in. It's actually pretty small. And we also, well, if I move my image here, you can see that it's got an X and a close. And you're familiar with computers, you know what those things do. So this X specifically is tied to what's going on right here. So I'm going to move my image back up, but now you know that X is there. And so what this loop is doing, this is running once every frame. So every time one frame is shown, all this code is run. Okay? It starts off with going through all the events that have happened since the last time it checked. An event is just basically any kind of user input. If you move the mouse, that's an event. You click a button, that's an event. You push a key on the keyboard, that's an event. You let go of a key on the keyboard, that's an event. And it all happened right here and said, okay, so everything that happened last time I happened or checked an event, go through all those events, and then we just are checking for one thing. It's checking, okay, is the type of event equal to quit? And really that's just meaning, did you click the X button? And so remember that X button, if we click that, that is creating an event of type quit. So that triggers this if statement, and so Pygame quits, and then the program stops. Okay, so that is what that's doing right there. Then this is very important. This must happen at the end of every frame. This is what actually updates the display to show the new frame. All right. So that is what all of this is doing. Notice that when we're creating the game window, it's being assigned to a variable, and this variable is in all caps. This all caps indicates that this is going to be a global variable, meaning we can access this thing from anywhere in our program. This is not something that is enforced by Python. This is a Python norm, and also in other languages. When you have a global variable that you want accessible everywhere, you define it in all caps, and that communicates to anyone else working on the same program that this is a global variable, and so you want to be a little bit careful with it. You don't want to change it because that's probably going to break stuff all over the program. It's actually the same reason why this is in all caps. It is a global variable. And we're going to be using a fair number of global variables in this program. So let's get started with writing our program or our game. First thing we're going to do is we're going to make use of a couple more imports. One thing we're going to make use of is we're going to import the time library. What this is for is if you notice that after I lost a game, it stopped for a little bit. That's what we're going to be using time for, is to put that stop before the next game starts so that the user isn't caught off by surprise when all of a sudden the game is going, they're not ready for it. So that's what time is going to be used for. We're also going to be using something called the NumPy library. This is used quite a bit when you're doing numerical stuff, but it has a couple things that are going to be useful for us as well. Specifically, we are going to want this for using vectors. If you've done any physics, you know what a vector is. If not, I'll kind of give you a brief overview when we get to it. So NumPy, I usually call it NumPy. It's a little bit more fun, but specifically it's called NumPy. So from NumPy, we're going to import array. Array here is a data structure, kind of similar to a tuple or a list, in that it has indices and it holds multiple things. But what's useful for us for this is that it also works as a vector, so we can add two of them together to get a new vector, and that's going to really help us when we're moving things around and identifying where we want things to be. We're also going to get the array equal method. So this is not a method, this is a data structure. This is a method, and what this does is it checks if two arrays, or in our purposes vectors, are the same vector. So for example, we might want to check if the snake's head is at the same place as the fruit or the apple. Well, we can do that by checking, okay, the vector that has where the snake's head is and the vector that stores where the fruit is, are those two equal? If they are, then the snake is at the apple. So that's what we're going to be using that for. Of course, we're going to want to randomize where the fruit shows up. So that means we're going to need to make use of the random library. But we're only going to make use of one method from that. So from random, we're just going to import the randint method, so we can just randomly generate integers. And that's it. Those are all the different things that we're going to need. Now, how about we make our global variables? So, global variables should be in all caps. One global variable we're going to want is how big each square should be. So, this is going to be measured in pixels. And in the game that I just showed you, each square was 10 pixels by 10 pixels. So you can change that if you want, but that's what we're going to be using it for. We also want to know, okay, in our game window, how many squares is it? Not how many pixels, but how many squares. Remember, each square is going to be 10 pixels here, but we can change it. I'm going to say, okay, the window length is going to be, let's say, 60 pixels. Not 60 pixels, 60 squares. And the window height is going to be 40 squares. Okay? So those are going to be fixed, and that's going to be telling us how big our game window is and how big our game area is going to be. I suppose I should also spell window correctly. Next thing we want to do is we're going to want to define some directions using our vector-like array thing here. And that's going to help us with moving around our snake. So left is going to be a vector, and so I'm going to use the array to construct a new array vector thingy. And left is in the x direction. You've got to think in kind of in Cartesian coordinates here. And left direction is negative in the x direction and 0 in the y direction. So one step left. If you're thinking in the Cartesian plane, where you've got your x-axis and your y-axis, if you want to go to the left, you're going the negative x direction. That's a way to think about it. And so right, you could probably guess, well, if left is in the negative x direction, then right must be in the positive x direction. And so there we go. So we got right and left defined, and that makes sense from what you know in math. However, in computer science and computer graphics, the y direction is a little bit different. So we have the up direction that we're going to make, and up direction is not moving in the x direction, it's in the y direction, and up is actually in the negative y direction, not the positive. Very different from how we think about it in math. The reason why is because the origin, when you're doing computer graphics, is in the top left-hand corner, right there. Okay, so if this was our total game window, right there is 0, 0. And as we go down, y becomes bigger. So this is the positive y direction and the positive x direction. So every point in here is represented by a 0 or positive x and a positive y value. And this is 0, 0. Okay? So down is in the positive y direction, up is in the negative y direction. That's why I have a negative there. And so down is the last one we need to make. And we're going to give it 0 in the x direction and positive in the y direction. Just one step. And the reason why I'm using 1 here is because I just want to go 1 in any particular direction, because that's how fast the snake moves. It doesn't jump squares, it just moves 1 square at a time. So we got those. Last kind of global variable that we're going to use are for colors. So we can make this, we could just assign variables for each color, but I'm actually going to make use of a dictionary for this. So I'm going to have my colors, I cannot spell, colors is going to be a dictionary. And I am going to then create a separate color for each different thing I want to color. And I'll just refer to this dictionary to identify what color I want everything to be, rather than having to say, okay, red is this, blue is that. I can just say, okay, I want to change the head of the snake to this color, I want to change the body of the snake to that color, etc. And so the key for this dictionary is going to be what it is that I want to color. So head is going to be what color is the head of the snake. And I need to make a color object thing that represents this. So the way we do that is we do Pygame. From the Pygame, we use the color object. Notice that Pygame is written by an American, so they use the American color rather than the Canadian color. For everything that I write, I'm going to do everything the Canadian way, but we have to be aware that sometimes Americans write code too. And so inside of this, we need to give 3 numbers, which are the RGB values of the color that we want. I am going to say our snake's going to be blue. So I'm going to give a red value of 100, a green value of 100, and we're going to go full blue. So the biggest number you can put in is 255. The smallest number you can put in is 0 for any one of these. If you want black, it would be 0, 0, 0. If you want white, it would be 255, 255, 255. And if you start playing with these numbers, you'll get different shades. So that's the color I'm going to have the head of the snake be. The body is going to be a little bit different, just so that we can tell what side of the head the snake is ahead and what direction it's traveling. So body is also going to be a Pygame color, and it's just going to be a kind of lighter blue. And to make it lighter, I'm just going to increase the R and the G values, but I can't get any bluer than 255, so that stays the same. Alright, now I need to have a color for the food. So food that the snake's going to have is also going to be a color, and I think I had the color to be kind of a red, so 255 red, and we'll do 100 of the other 2 colors. One last color to make, and that's going to be the background. What color do we want the background to be? Right now it's black. Black's okay, but let's do something different. So background is also going to be another color. And while we got a red, we got a blue. How about we make the background green just to kind of mix it up? So 100 of the red, 255 of the green, and 100 of the blue. There we go. And that'll be all the different colors that we have. And every time we want to color something, we'll just go into our colors dictionary. We'll give it a string saying what it is that we want to color, and it'll give us the color that we decided was going to be for that. And you can change these to be whatever you want. Okay? So, well, now we need to fix this, because this is going to create a screen that is 400 by 300 pixels. We need to make a screen that is going to fit using these values that we set, because this is actually going to tell us how big the screen needs to be. How many squares do we have, and how big is each square? So let's use those global variables to now fix the dimensions of our screen, so it's going to actually give us the right size. So it is going to be the X length, how many pixels we need, is how many squares we're going to have in the horizontal direction, so the window length, that's how many squares, and each square is square size. So that's how many pixels we need in the X direction. Likewise, we'll do the same thing in the Y direction. We'll do window, this time we'll do the window height times the square size, and that is how many pixels we need in the Y direction. There we go. We are also going to, well, maybe make some space. This is going to be our driver code. We're going to kind of do that a little bit later. But we do need one more thing, and that is a clock. And what we're going to use this clock for is to set the frame rate of our game. So Pygame has its own clock. It's under its time. Oh yeah, clock. Just like that. Create a clock to help track time. And we're going to use this to set what the frame rate is. There we go. Now we're going to need some functions. Now we're going to actually get it into making the game. We kind of initialize things. We set some stuff up that's going to be useful. Now we need to make some functions. First function we're going to make is something that's just going to draw a square on the screen where we want it to go and what color we want it to be. So we're going to say we're going to make a draw square function. It's going to take in two things: the position that we want the square to be drawn on our screen, as well as the color that it should be. Okay? And I'm just going to put pass in here. Remember, pass is just placeholder code. We're going to replace that later. But right now we want to identify what are the functions that we need. Then we're going to go and actually write all these functions and replace the pass with real code. So that is the first function we're going to make. We're also going to want to be able to draw the snake itself. And for that, we're going to pass the snake that we want to draw. That's it. The snake itself is going to be a list of vectors. So the list is going to contain every segment of the snake, and each segment is going to be represented by a vector indicating where that segment is on the screen. And we'll see that in a moment as well. We're going to have a function that's going to make a food for us, and it doesn't actually need to make any arguments. But this is just going to kind of randomly select a place on the screen to create the new food every time we eat one. That's it. Okay? So it's just going to randomly create a spot on the screen for where the next food's going to be. We're going to need something that's going to update our snake. So every turn it's going to be moving, and we need to have something that's going to update so it moves to where it needs to be on the next frame. Well, if we're going to do that, we need to give it the snake that's going to update. We need to know what direction the snake is moving, and we're also going to need to know where the food is so that we can tell whether or not the snake ate it during that frame. So those are the three things that this function needs to know so that it can properly update our snake. And finally, we got one more function that we're going to make, and that, actually, sorry, two more functions. We are going to create one that updates our direction, and it's going to take in the old direction, just because we need to know, okay, if we're not changing directions, we need to know which way we were originally going, just keep on going that way. And this is going to be where we actually get the input from our keyboard to determine which way should the snake be moving. Okay? And so that's what it's going to do. It's going to check the keyboard inputs, and based on the keyboard inputs and what direction we were previously moving, it's going to tell us what direction we should be moving now. Finally, we need something that's going to check if the game is over. So, did they run into themselves, or did they run into a wall? And for that, we just need to know what the snake is doing. So we're just going to give it the snake. It's going to do some checks to see did it run into itself or did it run into a wall. And if it did, it will tell us if the game is over or not. So those are all the functions that we're going to make. And then we're going to write some driver code. Just give me a moment here and we will resume shortly. Alright, I'm back. Now, what we want to do first, how about we do the draw square first. Let's just make our function that's going to be able to do all the drawing that we need. Since everything in our game is a square, the draw square can be used to draw anything that we want. So, to do this, we're going to make use of two things in Python, or Pygame. The first is called the rectangle object. And the rectangle object is mostly used for collision detection, but it can also be used to draw shapes. And a square is just a fancy rectangle. So, we're going to just draw rectangles on the screen. And for that, we're going to make a rectangle like this. Pygame rect for rectangle, and we need to give it a couple things so it knows where this rectangle is and how big it is. So first thing you can kind of see already what it's asking for. It has couple different ways that it initializes, but short version is that we need to give it where is it going to be and how big it is. So the first thing I'm going to say is, where does this square need to be drawn? Well, it's going to be drawn in the position given to us, but this position is not being represented by the pixel, but rather the square that we are drawing. And so to get the particular pixel that we want to draw it at, we need to take that position and we need to just multiply it by our square size. And that will tell us where on the screen is the top left corner of this rectangle. Okay? So position here is 0, 0. Multiplied by square size, well, that's still going to just give me 0, 0. Anything times 0 is 0. And so that will put us in the top corner here. If it was position 0 or 1, 0, that would be 1 to the left, or 1 square to the left, and that would maybe put it like right about there. You can see my mouse. And so it needs to be shifted over by 1 full square length, which is the square size. Okay? So that's kind of the idea of what's happening here. Is we're taking the position in terms of a grid of squares and multiplying by the square size to get the corresponding position in pixels. So that tells us where the top left corner of our square is going to be. Next, we need to say, how big is this square going to be? Well, we need to give its length and its height, or its width and its height. And I'm going to give this as a tuple. That's why I'm using round brackets here. And, well, we already know what a square size is. It's square size, right? Square size, that's the width of it. And then square size again. But this square size, if I can spell correctly, is the height. Okay? So this part right here tells us where to draw it, or the top left corner of the square, and it says what is its length and width. And that's it. That's all there is to a rectangle. Where did you put it? How big is it? Then we are going to draw this rectangle, square thing to the screen. So we say Pygame. We want to draw a rectangle, and we need to tell it 3 different things. We need to say, what screen are we drawing this rectangle to? We can have actually more than one screen. It's pretty rare, but it is possible. So what screen do we want to draw it to? We want to draw it to the display surface. If you get more advanced, you sometimes do draw it to other things and then draw that thing to the surface later. But we're going to draw everything to the surface directly. So remember, display surface is this thing that we created up here. So that is where we're going to draw our square. The next thing that we need to do is we need to tell it what color is this going to be. Remember, we're passing color also as a parameter here. So that's going to tell us what color the square is going to be. And finally, we need to give it the rectangle that it's drawing. So that thing that we just created up here, that's what goes in that 3rd spot. And that's it. Okay? And that's all there is to drawing a square. I suppose we could maybe test it out. So, down here in our driver code, we'll just do a little bit of testing just to show that it does in fact work. So we're going to do draw square. We're going to draw it in position 1, 1. So it's not quite in the top left corner. It'll just be offset by a little bit. And our colors, we're going to call whatever color we set the head to. And, oh, my indentation is not very good here. I like to initialize with different indentation that I typically use. Typically I just do 1 tab of indentation, This was using like a tab and a half or 2 tabs or something. So I just indented all that. So let's run. Let's see if it works. Da, 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 da. Oh, all right. I forgot about this. So we need to learn a little bit about installing Python packages. So it says from numpy or numpy, import array, and it says there's no module called numpy. Well, we need to tell it how to get that. The way we do that is we're going to go open a new tab down here, and we are looking for the shell. And what we're going to do is all modules in Python are handled by a package manager called pip. And so we're going to say pip, we need you to install numpy, just like that. And we hit enter, it's going to do some work, it's going to install numpy for us, and that gets rid of that error that we saw. Alright, and that's it. So, usually this stuff was all pre-installed before, but I guess Replic's done some updating. But now you know, if you end up using a library and it says, oh, I don't have access to that library, just do pip install whatever the library name is, and it will handle it all for you. Let's try that again. Oh, perfect. Nope, we got the window, and there's our square. So, we're now drawing squares to the screen. Perfect. Before we get into the snake, actually maybe we will get into drawing the snake next. So, this is just drawing a single square at the position given, and this position is a vector, or more specifically, it is an array given by numpy. The snake itself is just going to be a list of these vectors of where the snake is. And the first thing in that list is going to be the snake's head, and every other part in that is going to be part of the snake's body. So, knowing that, we can now do the draw snake function. And how we're going to do that? Well, we're going to get the first thing in the snake. Remember, snake is a list. The first element in that list is going to be the snake's head, so we're going to draw the snake's head. So draw square, use that draw square that we did. Position is going to be the first element in the snake list. And the color we want it to be is going to be colors, and the color we chose for the head. Colors, there we go. That draws the snake's head. Then we need to go through every other element, not the first one, but every other one, and draw those ones as well. So that sounds like a job for a for loop. I'm going to still say for, I'll say seg for segment, or maybe we'll just actually say segment. For segment in snake, but don't want to loop through the entire snake. We just want to get the part of the list that excludes the very beginning. You remember how to do that? Well, we can do that, right? We can get, this will split up that list into the section that we want, and we'll just say start from the second element and go all the way to the end. There we go. And then we're going to do draw square again. Draw a square. Position is going to be the segment. So remember, each element in our snake is a position, a vector representing where that segment is. So we're going, this segment represents one of the positions of the snake body. And then we need to tell it what color to draw it. And that is the colors, the body. That's it. There we go. This will now draw the snake for us. How we get on to the make food. Make food is just going to return a random vector of a valid location on the screen, and that's going to be where we draw the food. Pretty simple. And so we can actually do this in a one-liner. So we're going to returning a vector. Vector is an array, so we need to construct that vector, and now we need to randomly generate a x and a y coordinate for that vector. So the x coordinate this is going to be where we use that randint method to randomly generate an integer. And I find it really frustrating when the food is generated right on the edge of the screen. It kind of makes it a little bit tough. So I'm going to say that the food cannot be generated on the edge of the screen. It has to be somewhere in the interior. To do that, I'm going to say that its x position must be at least 1. So it can't be 0 because 0 is going to be the edge of the screen. 1 is going to put it just a little bit over. And the other side is going to be, window length tells me how many squares it is, and well, if I just did window length, that would be too far because that would put me 1 square over what we're actually drawing. So we don't want to include the endpoint. So normally that would be just -1, would be the last square on the screen. But we don't want to go to the last square on the screen because we don't want to be up against that wall. So we're going to do -2 to just bring us over 1 and keep it on the interior. Okay, so that is why we're using these values. Just so that we stay somewhere in the interior when we are creating our food. And then we're going to do exactly the same thing. Well, not exactly the same thing, but the same idea for the y coordinate. So once again, we're going to create a random integer. 1 because we don't want it to be on the edge, and then we'll do window height -2 so that it doesn't go off the screen or being on the bottom row there. And that's it. That is all we need to do for that function. That will create a random spot on the screen that is not on the edge, and that's going to represent where the next food is going to be. Update snake. Now we're going to get into kind of the more complicated stuff. Maybe we'll do... Yeah, I guess we may as well do the update snake now. Alright. So, we have the snake, we have the direction it's moving, and we have the food. This is going to be where we are really making use of vectors and vector operations. And specifically adding vectors together. So we're going to create a new variable called head, represents where the head of the snake should be now, not where it was last frame, but where it's going to be this frame. And it's going to be where was the head last time. Remember that first element in our snake list is the head. And then what we're going to do is we're going to add a direction vector, which is just going to offset it depending on what direction we are going. And the way that vector operations work is you just add the x components or the y components together. So for example, if the snake was at position, say, 1, 1, so second square to the right, second square down, and we add to it, say we want to go down, so that would be the direction 0, 1. That would tell us that the new direction that this, new position of the snake would be, well, 1 plus 0 is 1, and 1 plus 1 is 2. And so that would move us down 1 square. Okay? That is how vector operations work. You take the first numbers of each, or the x components of each vector, add them together. That's your new x coordinate. Y coordinates of each one, add them together. That is your new y coordinate. Real simple. We could write code that would do this for us, but we already have something that will do vector addition for us, so we may as well use that, and that's why we're using NumPy. Okay? So, this is just saying, depending on what direction we're going, add that to where the snake is. That's going to be where the new snake's head position is going to be. Okay? Then, now we need to do a check. Because we have two different situations that we need to consider. Did we just move normally, or did we move and eat a fruit or a food? So, what we're going to do is we are going to check using that array equal method. And what we want to know is the new head position in the same position as where the food is? Are those two in the same position? If they are, then, well, the snake needs to grow by 1. So our new snake is going to be, well, we got where the head is. Putting square brackets around it turns it into a list just containing the head. And then we're just going to add to that list the rest of the snake. And note, well, the snake, say the snake had a length of 5 or whatever, and if I just add the head position to it, then the snake didn't really change its position, but it's 1 longer. And the head is now where it needs to be, but the tail of the snake didn't really move because it grew, because it ate a food. Okay? So this actually makes a snake 1 longer, which is what we want when we eat a fruit, right? That's kind of a core mechanic of the snake game. Otherwise, if the head did not eat the food, then we need to create the new snake. And the new snake is once again going to be the head, but we're not going to add the whole snake. The whole snake, because now the snake needs to move. And so its tail needs to move forward 1. And the easiest way to do that is we're just going to take the whole snake again, add it to the head, but we're going to drop the last item in the snake's list, which was its tail. And this does almost the same thing, but the last part of the body on the screen will be dropped. And the head will be attached, the new head will be attached, and this will create a snake that's the same length, but is moved forward 1. Okay? So that's the logic of what's going on here, is we're updating where the head needs to be. Based off of whether the head ate a food or not, we are creating a new snake list. And then, what do you think we're going to do? We're just going to return that snake. Okay? And that updates where the snake should be, based off of where it was, what direction it's going, and where the food is. Alright, so we've got 2 more to go, and then we can get into this driver code. And maybe we'll get rid of this testing code since now we already know that our draw square function works. So update direction. This is going to be handling all of the user input for us. And normally, user input is done by this, but we do have an alternative. And the alternative that we're going to use is just to check what keys are currently being pressed and use that to determine what should be done. So, first of all, we need to know what keys are currently being pressed. So I'm going to create a new variable called keys. This is going to be a dictionary that tells us what keys are pressed. And Pygame already gives us a way to access this. So we do Pygame, key, and get pressed. And that's going to give us a dictionary of all the keys that are currently being pressed. Well, actually all the keys, and the value is going to be true if that key is currently being pressed and false otherwise. Okay? Then we're going to go through this, check the different keys, and use that to update what direction we're going. So we're going to do WASD for our controls. So we're going to say if keys, and we're going to check, okay, is the W key being pushed? Well, the key that we need to give to our dictionary here is Pygame dot K capital K dot capital K underscore W. Okay? And I suppose I should also name Pygame correctly. That's it. So go into Pygame, get the constant K underscore W. This is how Pygame refers to all of the keys. Is K stands for keyboard, underscore separates keyboard from what key, and then the second letter here is which key are you pressing. Special keys like up and down and whatnot are slightly different. I believe it's just up down rather than an arrow. But all the letters and numbers, they all work like this. Okay? So this is checking if the W key is currently being pushed. Keyboard, W key. Alright? And if it is, well, the direction we're traveling is up. And remember, we defined up here. Right? It's just a vector that goes up by 1. And so that's where we're using all these variables for. elif, and we'll just do this for, we did it for W, now we got ASD to do, and we'll just return the corresponding ones. So if keys, Pygame, what do you think it's going to be for A? Well, keyboard, A key. And spell Pygame correctly. And A is our left key, so we're going to return left. elif keys Pygame S, so KS. S is our down direction, so return down. And elif keys Pygame, well, what if last one we got is D, and you guessed it, KD. Return right, because D is our right key. Wow, I am really terrible at spelling Pygame. There we go. Alright. So this is going to check what keys are pressed, and depending on which one is currently being pressed, it's going to return that direction. Note that you can't hold down multiple. Like if you hold down W and D at the same time, well, the first one it's going to run into is the W key. So it's going to return up. Okay? So, got to be careful when you're playing. Don't hold down multiple keys. It's not going to necessarily do the one that you think it's going to do. This is going to go through all these in order. So if up is pushed, it's going to do up. Not even bother checking any of the other ones. But what if none of these keys are pressed? Well, we should keep on going in the same direction that we're already going. And that's the reason why we passed it the direction we were going. Because we need to know what direction we're going in case if no keys are being pushed, we need to say keep going the same direction you're already going. One thing that you may want to do, because part of this assignment is that you're going to have to add on to this code afterwards, and this code right here only will allow you to move in any direction you want. In the real Snake game, that's not actually possible. You can only turn left or right from the direction you're going. You can't do a UE, but this would allow you to do a UE. Like if you're going right initially, and then you hit A, you'll automatically start going left, but that should not be allowed. So, you may want to consider changing this or adding to it so that you can only go left or right from the direction you're currently traveling. But for now, that's going to be good enough for us. Finally, check game over. And the game can end in two different ways. You run into a wall, or you run into yourself. So those are the two things that we're going to look at. So, first thing we're going to look for is, did you run into a wall? To do that, well, we only really need to check where the head is, because the head is leading everything. The body's not going to go anywhere where the head hasn't already been, so the only thing that's going to run into a wall should be the head. So we're going to check the X and Y position of the head and use that to determine did it run into a wall. So if the snake, get the first thing in snake, that is the head, gets the X position of the head. So this is like the first number in that array. So that's getting the X position of the head. And we're going to say if that is not in the range between 0 and the window length, return true. What this is doing is saying, okay, is the X position a number between 0 and the number of squares we have going horizontally, not including the endpoint. If it's not one of these, so these are all the valid X positions it could be, if it's not one of those, it ran into a wall. That simple. And so we're going to return true. Yep, the game is over. And then we're going to do the same thing with the Y direction. In fact, we could actually put it all together in one, but we may as well just do it in one. So snake, now we're going to get the Y direction. Y direction is the second thing in that vector. And once again, we're going to check if it's in the correct range. So it has to be between 0 and the window height. And then we're going to return true if it's not inside of that range, because that means it ran into one of the walls. That's it. That handles the first case of how the game can end. Did you run into a wall? That checks if you ran into a wall. Now we need to say, okay, well, did you run into yourself? Well, to do that, what we're going to do is we are going to get the head position and see if the head is in the same position as any segment of the body. Well, the head is always going to be in its own position, but if the head is in the same position as any of the body segments, you ran into yourself. So that's going to be how we check. So we're going to loop through all of the body segments. So for segment in, and we saw this when we were drawing the snake function. When we wanted to loop through just the body, we say start from the second and go all the way to the end. So that gets us all of our body segments. And then we're going to check using the array equal method from NumPy. We want to know if the head is in the same position as any of the segments. And if it is, we're still going to return true. The snake ran into itself. Game over. So that's the second way that you can use the game, where the game can end. And if neither of those happened, you didn't run into a wall, and you didn't run into your body, then the game's still on. So we're going to return false. The game's not over. There we go. That's it. And those are all the functions we need. Now we can actually get into making the driver code, and then we'll have a full game going. So we're going to keep most of this, but we're going to modify it. One thing we're going to do is we're going to put it into proper driver code. So if name equals main, quotations. You've seen this in a bunch of your assignments. If I haven't explained it to you before, what this is doing is saying only run this code if this program is run directly, or this file is run directly. If it's not being run directly, don't do that. Okay? And then we're going to actually have two while true loops. This while true loop is happening every frame, and it's basically going to be going on while the game is still going. But when the game ends, we need to start a new game. We need some initialization to happen before we get into this main loop. So we're going to make another while true loop. That this is going to be inside. And inside this while true loop, we're going to do all the initialization that we need before we actually start the game. What initialization do we need to do? Well, we need to have a snake, right? We got to have a snake to begin with. So let's make our snake. Remember, I told you it's going to be a list of vectors, and it only starts off with just the head. So we just need to populate our snake with the head. And to make things fairly fair for our player, we're going to make it so that the snake always starts in the middle of the screen. How do we do that? Well, we say, okay, well the X position is going to be the window length divided by 2. If the window length is the whole screen, then half of that will put us in the middle of the screen. And then we're going to do exactly the same thing, well, not exactly, but same idea, to get it into the middle screen in the Y direction. We're going to say the Y position is going to be the window height divided by 2. And why do you think I'm doing double divide? The reason why is because I want it to be an integer. We are drawing this to a specific spot. Everything is being represented by whole numbers. If I said I want to draw this snake at position pi 0.7, what the hell does that even mean? No idea. These need to be whole numbers. And double divide always gives me an integer, a whole number. So that's why I'm doing that. Next, I need to set what the initial direction is going to be. So dir for direction. And the initial direction we're going to make the snake go is up. So snake starts off going up. Simple. And we also need to make the food, right? So we're going to go and say the food is going to be, and we'll just call our make food function. Simple. So that makes all the different things that we have. Now we're going to want to do a little bit of initialization. So what we want to do is we don't want to start the game right away. We want to kind of show the starting position of everything, wait a little bit, then have the snake start moving so that the player isn't caught by surprise and automatically lose right away because they weren't ready. So basically it means that we're going to need to just draw the first frame. So we are going to take our display surface and we are going to start off with filling it with the background color. And this is going to make, rather than everything black, whatever color we chose. I think we chose green. Sounds about right. So we're going to get into our colors, and we want to fill it with the background color. Okay, and we do this first because everything that we draw gets layered over top of it. So the back layer gets drawn first, then as you keep on drawing things, it gets drawn on top of what's already there. That's why we're doing this fill first. Then we're going to draw the food and the snake over top of it. And, well, let's do that. Let's draw our snake. We'll give it the snake that we want to draw. We need to draw the food. We didn't have a draw food function. We could make one if we wanted, but we're just going to do a draw square. We're going to draw the square where the food is, and the color is going to be, well, from our colors, the food color. I did say food, right? Let's double check. Yeah, food. And there we go. That will draw the food for us. Just a single square. And then we're going to wait a little bit. And this is where that time that we imported is going to be used. So come back down here. I'm going to say time. We want to sleep, which is say do nothing for a little bit. I'm going to say let's sleep for 2 seconds. So the player gets 2 seconds to get ready before the snake starts moving. It'll draw everything. And that should be all the initialization that we need right away. Then we can go and we can get into, while the game is running, what do we need to do? Well, handle all the events. The only event that we're going to be looking for is if they hit the X button to stop. So we're not going to touch any of that. But what we're going to do next is, typically when you're dealing with any kind of game or game engine, you separate into two different parts. You update every game object, then you draw it to the screen. You do those two things separately. So that's going to be what we do first, is we're going to update everything, then we're going to draw everything. Updating, well, one thing that needs to be updated is what direction we're going. So our direction, we're going to call our update direction function, give it the direction that we're currently going. And this will now check the keyboard, see what keys are being pressed, and update our direction so that our direction is what it's supposed to be. First update done. Now we need to know, okay, we need to move the snake. That is another update that we need to do. So we need to do our update snake function, pass it the snake that we're going to be updating, the direction we're going, and where the food is. And that will update our snake to where it needs to be for this frame. After that, we need to do two more things. We need to check, okay, is the game over? That's another update we should check before we draw the frame. So what we're going to do is call that check game over function, pass it our snake, and if it returns true, the game is over, somehow the player lost, we're just going to exit out of this loop. So this is our inner loop that happens while the game is running. If it's game over, we stop, goes back to the beginning of this, and does all the initialization for a new game. Then it'll go back in, and we keep on playing. We also need to check, did they eat the food, in which case we need to generate a new food and place it on the screen. Well, what we can do is we can just check if the snake's head is where the food currently is. And we've already seen how this works, right? We say, is the head of the snake, or snake 0 is the head of the snake. Food is where the food is. Are they in the same position? If they are, then we're going to make a new food. Just like that. Okay, everything's updated. Now, we need to draw everything. So, actually, we've already seen how to draw stuff. Drawing the snake, draw the square. I'm just going to actually copy this and paste it down here. Fix the indentation. There we go. Draw the snake, draw the square. I am missing one thing though, and that is we need to draw the background first. So let's scroll back up and get that background as well. That's going to fill in the background. So first draw the background, then draw the snake, then draw where the food is. Finally, we need to make use of that clock that we made. So everything is drawn, we've updated the display. Now, that clock that we made, remember clock is right here. And we are going to use this to set the frame rate. Normally, this will run just as fast as it can. And sometimes frames will be fast, sometimes frames will be slow, depending on what's going on. We want things to kind of run at a consistent rate. And so what we're going to do is we're going to do call tick. And then we're going to say, what is the frame rate that we want? How many frames per second should we run this game at? And this is a pretty simple game. And if we're have a really fast frame rate, our snake is going to move really fast. It's going to make for a tough game. So I'm going to actually say we only want this to run at 15 frames per second. Sounds pretty slow, but it will be plenty fast. It means it's moving 15 blocks frame, and well, we only have 60 blocks wide, so going from one side to the other is only going to take 4 seconds. You can change that if you want. Just telling you that's what it represents. And that's it. This game should now work. So I'm going to kind of slide this over. Slide this down to get some screen space here. And let's try it out. Oh, there it goes. So everything seems to be moving. And let's see if I can get that. Oh, there we go. See, my snake grew. Food moved. Everything looks like it's going pretty well. And, oh. You notice that, couple things. It is pausing, but it's not showing where everything is supposed to go. And because my screen is super zoomed in right now, just to make everything a whole lot easier for you to read, you can't actually see the bottom of the screen. So, second thing is not actually an issue. If I unzoomed in my screen, everything would show very nicely, or I could just make things smaller. But to fix the other issue, and so that when we're doing the sleep, we can actually see what the start of the game looks like, we need to call this update function. Because this is actually what changes what the frame is showing. Since we did not do this here, everything got drawn, but we didn't display the new frame. And so it wasn't until we got through the second frame that we actually see anything going on. So we're going to put in an update right there. That's going to then show us what the first frame is, then it'll wait. And in order to make it so that it fits on my screen a little bit better, I am going to change the window height to 30, and maybe I'll change this to 40. So I'm just going to shrink things down a little bit, and we will run it again. Well, everything seems to be showing real nicely. It stopped right at the beginning, like it's supposed to. And I am terrible at this game. Oh, there we go, I'm getting a couple. And how about after I get this one, we will quit the game. And there we go. Alright, just run into it. Stopped. And waits 2 seconds, then it starts moving. And you can see, even with 15 frames per second, it's moving pretty fast. Okay, so we're going to stop there. What you must do now is you need to comment on all of this code. Tell me what everything does, because while we wrote it together, I did not add any comments. I just talked about it as I was writing, so based off of what I was saying, you can use that to say what everything was doing. And then you need to add on to it. So I made just a real basic version of this. You need to add on some stuff. So you could have poisonous food. If they run into it, game ends. Looks like my connection was not great. Oh well. You can make it multiplayer so that there are 2 snakes. Have each player control one and see which one can get longer. You may want to look into adding text to it so it can tell you like how long your snake is. And all sorts of different things that you might want to add on to this to make it your own. Okay? So we'll stop there, and until the next time, adios.